identities. The sum and difference identities tell me that if I'm adding or subtracting an angle, and I know these formulas, I know what it comes out to. So for instance, if I know, now don't get lost in the A's and B's, those are just placeholders. These could be X's and Y's, Y's and X's. Okay, so if I know the sine of an angle plus an angle, so let's say this is 30 plus 45. I know how to find the sine of 30 degrees, I know how to find the sine of 45 degrees. So I'm looking for the sine of 30 plus 45, which would equal 75. This formula will get you that sum. That is finding the sine of A, which in this case would be 30 degrees, cosine of 45 plus cosine of 30, sine of 45. If you do this, you will then know the sine of 75 degrees. So the whole thing today is understanding what these formulas are doing. These formulas are allowing me to add or subtract angles so I can put values on the unit circle that traditionally aren't on the unit circle. And I can actually get exact values without using my calculator. Now, sine, it's kind of cool. It's sine cosine plus cosine sine. If it's subtraction, it's sine cosine minus cosine sine. Cosine is the trippy one. Even if I write these out, people still get it wrong. Because if I'm adding angles, it's actually a subtraction on the other side. This is not a misprint. This is a subtraction on this side. So if I have 30 plus 45, I better have a subtraction. This one is cosine cosine minus sine sine. If you're subtracting angles, cosine cosine plus sine sine. Tangent, obviously the harder of the two. We take tangent of the first angle plus tangent of the second angle, all over 1 minus tangent of the first angle times tangent of the second angle. Let's actually just get into doing one of these. I think that's the easiest way to look at these. All right, so we're supposed to find the expression tangent of 7 pi over 12. Is 7 pi over 12 on the unit circle?
No.
No, it is not. So we can't just go straight to an answer. So it is not on our unit circle. So prior to today, we'd have to plug in our calculator. But we can express this as an addition of angles or subtraction of angles. Now, here's where it gets a little difficult. We know key angles on the unit circle. We know 0, pi over 6, pi over 4, pi over 3, and pi over 2. Now, just on the surface, can you easily picture what two angles you could add together to make 7 pi over 12?
Pi over 3 and pi over 6.
We'll find out. Let's check it. So I'm going to show you an easy way for everyone who's just like, no, I can't picture that. That's fine. Because none of them are in over 12. So what I'm going to do is I'm going to go to the other side, and I'm going to make a list to myself. I'm going to make a list of key angles that I know the values of the unit circle. So I'll do pi over 6. I'll do pi over 4. I'll do pi over 3. And maybe I'll do pi over 2. Those are all my from first quadrant that I could probably add or subtract to make this. Now, to make my life easier, let's make them all have a denominator of 12. Let's make every one of these have a denominator of 12. So instead of pi over 6, I multiply the top and bottom by 2, and I have 2 pi over 12. Pi over 4, I multiply the top and bottom by 3, and I have 3 pi over 12. Pi over 3, multiply the top and bottom by 4, and I have 4 pi over 12. And finally, pi over 2, multiply top and bottom by 6, and I have 6 pi over 12.
Oh, it's pi over 3, not pi over 6.
I have to make 7, right? 7 pi? Do we see two of these up here that when added would equal 7 pi?
Yeah.
I have 3 pi over 12 and 4 pi over 12. So I'm going to use these because these two equal that 7 pi over 12. Now I'm going to use the pi over 4 and the pi over 3 because that's what's on my unit circle. So I'm going to say, okay, you give me tangent of 7 pi over 12. I'm going to kick something back out at you. I'm going to say that's the same thing as tangent of 3 pi over 12 plus 4 pi over 12, or just pi over 4 plus pi over 3. Does it matter if I do pi over 4 plus pi over 3, or if I flip those?
No.
Would 4 pi over 12 plus 3 pi over 12 equals? Yeah. Addition doesn't matter which order. So it doesn't matter which is your A or B. Doesn't matter. If Reed does pi over 3 plus pi over 4, he'll get the same answer as if I did pi over 4 plus pi. You get the exact same answer for plus. If you're subtracting, you have to do in the proper order. And we'll get to one of those. All right, so now I have tangent of an angle plus an angle, so we go up here. And we're like, oh, well, I just have to find the tangent of the first angle plus tangent of the second angle. So we're going to say, well, this is the same thing as tangent of the first angle, which is pi over 4, plus tangent of pi over 3. Now that's all over 1 minus tangent alpha times tangent beta, or tangent of our first angle times tangent of our second angle. So this is going to be 1 minus tangent of our first angle times tangent of our second angle. Now, the reason why we did this is because these are values on my unit circle. So now we can go to our unit circle and actually plug in all of these numbers. So help me out here. What's the tangent of pi over 4? It's just 1. Yeah, pi over 4 is that nice one. That's just 1. Tougher one, what's the tangent of pi over 3? It's just square root of 3. Yeah, because it goes square root of 3 over 3, 1, square root of 3. So we have to go back to knowing how to use our unit circle. So this is square root of 3. The nice thing is if I have the top ones done, the bottom ones are just going to fall in place because this is just going to be 1 minus 1 times square root of 3. Or realistically, that's just 1 plus square root of 3 over 1 minus square root of 3. Here's where you're going to hate doing tangent. Tangent is the hardest one, for the most part. Because what are you not allowed to have in the denominator?
Square root.
A square root. Now, normally getting rid of square roots is easier. Just multiply the top and bottom by square root of 3. However, it has a 1 in front of it. You have to multiply by the conjugate. Conjugate works just like the conjugate for our trig stuff. If it's 1 minus square root of 3, the conjugate is 1 plus square root of 3. If I had 1 plus square root of 3, the conjugate would be 1 minus square root of 3. So we're basically creating a difference of squares. So we're going to multiply the top and bottom by 1 minus square root of 3, top by 1 minus square root of 3. The bottom's actually easy, the top is the hard part. Oh, I'm sorry, we're supposed to do 1 plus. I said the opposite of what I wanted to do. We want 1 plus because I want to get rid of the denominator. The denominator is 1 minus square root of 3, so I need to multiply the top and bottom by 1 plus square root of 3. All right, the top one you have to fully distribute. So I don't care what method you use. Some people draw like those little boxes and stuff. Some people use FOIL. I just do this method. I take the first number and distribute it. So I take that first number and distribute it. 1 times 1 is 1. 1 times square root of 3 is square root of 3. Then I take the second number and distribute that. So I basically have 4 arrows. I have this one going to everything over here, and this one goes to everything over here. Square root of 3 times 1 is square root of 3. And then we have square root of 3 times square root of 3, which is 3. Square root of 3 times square root of 3 is 3. I've been pretty harpy on difference of squares, right? Because it shows up a lot in this chapter. This is 1 minus 1 plus, so it's going to turn into 1 squared minus square root of 3 squared. So we're going to have, on the bottom, we'll have 1 squared plus square root of 3 squared. What's square root of 3 squared? 3. What's 1 squared?
1.
What's 1 plus 3?
4.
4. Okay, so we really just have, on the top, we have a 1 plus 3, which is 4. Square root of 3 plus square root of 3, turns out that means you have 2 square root of 3s. And that's all over 4. Now you could go further. I'm only worried to go forward if it meets one criteria. Does the 4 go into both of these items? If it does, you have to go forward. If not, you don't. So I'm just going to put this as maybe it. So just in case it did, we would do something like this. We'd rewrite this as 4 over 4 plus 2 square root of 3 over 4, which would equal 1 plus square root of 3 over 2. I put it in red because it's optional because the 4 didn't go into both items. Only if the 4 goes into both items are you required to do that. Yeah. Yeah.
So would that be since 4 doesn't go into both, is that the final answer?
I'd be okay with the first one. Yeah.
But if it was multiplication, you could just take the 4 out, right?
What was that?
If it was multiplication, you could just take the 4 out.
If it was 4 times 2.
It's 4 times, yeah. I was going to say, this looked weird. Where's my mistake?
Oh,
Where's my mistake?
In the last part?
Because this isn't right. I looked at this and this just can't be right.
Is it the last part? Or did you not simplify that part?
There's a mistake up there. Where is it?
Oh, you didn't do square root 3 squared?
no, we did.
I
Yeah,
did.
you did.
No.
I'll tell you, it's between the
No,
purple.
it's in the,
Wouldn't it
the
be
black one, right? The last one? That
Here?
part?
Yeah.
Yeah.
No, wouldn't it be 1 minus square root of 3 instead of 1 plus square root of 3?
It should be 1 minus.
Uh,
It should be 1 minus. There is my mistake. So we actually have a difference of squares here.
Do I get bonus points?
Sure, if you remind me when we check this homework. Just remind me when we check this homework. So that should be a minus. What is 1 squared minus 3? Negative 2. So this bottom should be a negative 2. Does 2 go into 4 and 2? Yes. So this one, I'm going to get rid of it being in red because you have to do it then. So I'm going to rewrite this as 4 over negative 2 plus 2 square root of 3 over a negative 2, which is then going to equal a negative 2 minus square root of 3. That makes sense because this one should not have a fraction in it. Do you want to rewrite yours? Okay. I do want to point something out. For people that are getting bogged down in this stuff, most of your points come from here. If you have this correct, this is most of the points on the test. Simplifying is just that cherry on top, that extra point that you can get from that. And just so you know, as long as you do most of it correct, you can get like half those points. Leave that up for one more second. Make sure you changed it if you didn't already change it.
So that's the tangent of 7 pi over 12.
That is the tangent of 7 pi over 12, the exact value. If you type in your calculator, you would get this out, but as a decimal approximation, but it'd be the exact same answer.
Are all of your homes going to be like that long? What's in it?
No, tangent is terrible.
Like, this
So this
is pretty
one-
long for.
Yeah, let's. I always get the hard one out of the way, then we'll go to some easier ones. The hardest part should be knowing the formula, which will be given to you, and coming up with the correct angles. Okay, so this one's going to be a lot quicker. So this one, once again, I have pi over 12. So that means I'm going to write out angles that I know the values of. I know pi over 6. I know pi over 4. I know pi over 3. I'm just going to leave it at those big 3. We could add pi over 2 as well. I'm just going to leave that out for right now. All right, to make these 12, it would be 2 pi over 12. 3 times 4 would be 12, so I'll have 3 pi over 12. And 4 times 3 would be 12, so I'd have 4 pi over 12. Can anyone look at a way that I would add those together to make just pi over 12? No. So we're going to use subtraction. We're going to use subtraction instead of addition. Can anyone see 2 angles that I could subtract that would make this work?
Pi over 4 and pi.
Pi over 4 and pi over 6? We could use either one of them. We could do, what's 4 pi minus 3 pi? 1 pi.
Yeah.
What's 3 pi minus 2 pi? 1 pi. It doesn't matter which one we use. We can either do 3 pi over 12 minus 2 pi over 12, or we can do 4 pi over 12 minus 3 pi over 12. So either one of those will work. We just have to pick one. Which one are we picking?
4 and 6.
You said 4 and 6?
Sure.
Okay, so we're doing the 3 pi over 12 minus the 2 pi over 12. Now, I usually write this in there to make sure I write it in the right order. Because we don't want to do 2 pi over 12 minus 3 pi over 12. That's negative pi. So we got to make sure these are in order. That's why I usually take the time to actually write them correctly. Because that equals pi over 12. Well, that came from cosine of pi over 4 minus that pi over 6. Now, the nice thing is we just got to plug it into the equation. It's just plug and chug. We have the subtraction one, so it's going to turn out we're going to have an addition in there. I do want to be clear, that subtraction only affects which one of these we pick. I am using the pi over 12 and the pi over 6, not negative pi over 6. That's the mistake I usually see. I see people plugging in negative pi over 6. The negative just tells you which one to use. Your angles will be both positive in these because they're both positive pi over 4 and pi over 6. What was that? I'm going to use the one on the right. That says, okay, if you're subtracting two angles, we do cosine first angle, cosine second angle. So cosine of my first angle would be pi over 4 times cosine of my second angle, which would be pi over 6. Then it says to put a addition sign, which is tricky, but it's the equation. And then we're going to go, okay, it's sine of our first angle times sine of our second angle. Now, hopefully we know the cosines and sines of pi over 4 and pi over 6. They're pretty early in our unit circle. What's the cosine of pi over 4? Oh boy, I think a lot of us need to take out our, because we got one guy doing it all. If you don't know this stuff, you better have a unit circle out. What was it? It's square root of 2 over 2. I agree with that. What's the cosine of pi over 6? It's square root of 3 over 2. What's the sine of pi over 4? Square root of 2 over 2. And what's the sine of pi over 6? 1/2. Square root of 2 times square root of 3. Remember, if you have square roots, you actually multiply what's under the square root. So square root of 2 times square root of 3 is square root of 6 over 2. Actually, it's over 4, right? Because 2 times 2 is 4. Plus square root of 2 times 1 is square root of 2. 2 times 2 is 4. Do they have the same denominator?
Yep.
Let's push them together to give us square root of 6 plus square root of 2 all over 4. Done. Easier than tangent, right?
Oh, yeah.
Yeah. Tangents are the upsetting ones. You're like, I don't want to do another tangent one because that means you have to do that stupid conjugate thing to get that square root out. But cosines and sines are basically, do you know the formula? And then plug and chug.
And then you give us the formula. So it's like,
And then I give you the formula. So you only have half the thing. You just have to plug and chug. Obviously, you got to be able to figure out this stuff. So those of you that aren't putting this down, don't be lazy. Put it on the test. Get it correct. Don't just in your head visualize everything. That's when you make dumb mistakes. All right, so our last one is, we're doing sine. We're doing 15 degrees. Okay, so now we have to go back to degrees. Some degrees that I know. I don't know 15 degrees, but I know 30 degrees. I know 45 degrees. I know, what else do I know? 60 degrees. Do I need any more? No, because we could go 90. We can keep going. How can I get 15 degrees out of these? 45 minus 30. So you probably didn't need to write these out because you can just go, you know what? Sine just, this will be 45 minus 30 degrees. As a reminder, the negative says just look at the negative one, but we're still going to use the angle 45 degrees and 30 degrees. The negative just tells you what formula to use. So we're going to use the one with the negative sign. For these, it's sine cosine minus sine cosine. So sine of 45 degrees times cosine of 30 degrees minus sine cosine, cosine sine, So we'll have cosine of 45 degrees, sine of 30 degrees. Now it just takes, do you know your unit circle? Practicing it all semester. What's the sine of 45 degrees? Square root of 2 over 2. 30 degrees for cosine. Square root of 3 over 2. Minus cosine of 45 is square root of 2 over 2. Sine of 30 degrees is 1/2. That's going to give me square root of 6 over 2 minus square root of 2 over 2. Am I making any mistakes that I should stop and check myself? It should be a 4. What's 2 times 2? 4. Both of these need to be 4s. So I should have square root of 6 over 2 times 2, which is 4. Square root of 2 over 2 times 2, which is 4. Common denominator, we rewrite this as square root of 6 minus square root of 2 all over 4. And that's it. Any questions on any of that? Okay, then the rest of the time is yours to work and ask questions.